Dear students, very good evening. Today we are going to discuss about how to solve minimization problem using simplex method. Here we are having a problem that is given as minimization of z equal to x2 minus 3x3 plus 2x5 subject to the constraints 3x2 minus x3 plus 2x5 less than or equal to 7 minus 2x2 plus 4x3 less than or equal to 12 and minus 4x2 plus 3x3 plus 8x5 less than or equal to 10, whereas x2 x3 and x5 are greater than or equal to 0. So we know that whenever we are having minimization problem, we want to convert it as maximization problem. So here we are writing it as maximize of minus z, and again this minus z is transformed to maximize of z star. Okay, after writing this maximize of z star on left hand side, we have to multiply the right hand side by minus, so we get minus x2 plus 3x3 minus 2x5. And now we are going to do our next steps. So the next steps consists of following iterations. So we want to remove these inequalities. We want to remove these inequalities, and instead of these inequalities we want to introduce equal sign. So when this inequality will get eliminated and we will get equal to sign means when we add a slack variable, when we add slack variables s1, s2 and s3 to these three constraints respectively means we will get equal sign here instead of less than or equal to sign in all the three constraints. So what is mean by slack variable? Slack variables are nothing but the variables that are added on the left hand side of the inequality to make this as equal to right hand side. So we are having maximize z star equal to minus x2 plus 3x3 minus 2x5, and these constraints, since there are three constraints and these three constraints are having less than or equal to sign, we want to add slack variables s1, s2 and s3. If suppose one of the constraint is greater than or equal to means we want to introduce surplus variables, but in most cases we convert these into less than or equal to sign and we want to add slack variables in simplex method. Okay, so for simplex method we want to maintain this less than or equal to inequality, and after that we want to convert it as equal sign by introducing slack variables. So after introducing these slack variables in three constraints, we have to add these slack variables with zero coefficients in the objective function. So after that we want to write this table. This table is called simplex table. Here in the objective function we are having minus 1 and 3 and minus 2 and 0 and again 0 and once again 0. So this minus 1, 3, minus 2, 0, 0 will become our Cj, and in the right hand side of the constraints we are having 7, 12 and 10. Those values become our xb value. Okay, and the coefficients of s1, s2 and s3, what are these three? These three are basic variables. These three basic variables can be found by setting number of variables minus number of equations equal to 0. Here the number of variables are 6, number of constraints are 3, so we are having three variables three variables. So we have to make three variables equal to 0. So we are not taking these s1, s2, s3 as 0. Instead of that we are taking these x2, x3 and x5 in all the three constraints as 0. So we get s1 equal to 7 and s2 equal to 12 and s3 equal to 10. So why we are taking these 3 as 0 and not s1, s2, s3 as 0 means, because if we take these 3 as 0 means the purpose of adding this to make the inequality as equal sign become failure. So we are giving more preference to make 0 to this x than s. Okay, that is the reason. So we are getting s1 equal to 7, s2 equal to 12 and s3 equal to 10 as the basic variables, and remaining x2, x3 and x5 are all equal to 0 and they are called non-basic variables. So now in first iteration we are introducing this aij. So 3 minus 1 2 1 0 0. 3 minus 1 2 1 0 0. And again from second constants we are having minus 2 4 0 0 1 0. And again from the third constants we are having minus 4 3 8 0 0 1. Okay, now zj star minus cj star has to be calculated. So for this we want to multiply 0 on the 7 and again 0 on the 12 and again 0 on the 10, and we have to add all the values. Okay, and we are getting only 0, and to calculate the remaining zj star minus cj value we want to multiply once again 0 into 3 and 0 into minus 2 and again 0 into minus 4, and all this has to be added and they will only give 0, and after that we have to subtract this cj. So 0 minus of minus 1 will give plus 1, and after that we are having minus 3, and after that we are having 2, and after that we are having 0, and after that we are having 0, and after that we are having 0 again. Here we want to choose the negative element. If we are having all elements as positive means there is no problem, we can stop the problem by here itself. Okay, and the only thing is we want to find we want to write solutions from this iteration. Here we are having negative value, so we are not supposed to write the solution from this iteration. So we want to make all zj minus cj as greater than or equal to 0. So since this is most negative, if we are having another negative element means we want to choose most negative. Okay, if we are having two negative elements as equal means we want to choose either of those two equal negative elements. So here 3 is the only negative element, so we are choosing this as our pivot column. So after that we want to find theta equal to minimum of xb divided by a I j, such that a I j is always positive. aj is always greater than 0. aj is always positive. Here we cannot write 7 divided by minus, we cannot write 7 divided by minus 1, we cannot write 7 divided by minus 1, because here in the denominator we are having negative, so it is not possible. So it is not possible. Okay, and then here we can write 12 by 4 and 10 by 3. 12 by 4 gives the value as 3, and after that this 10 by 3 gives 3.33. So out of this, the 3 is the minimum value. So this is our this is our pivot row. This is our pivot row, and the intersection of pivot row and pivot column. The intersection of pivot row and pivot column. Intersection of pivot row and pivot column is called pivot element. Is called pivot element. Okay. So here 4 is the pivot element. So we want to divide uh, this equation by 4. So here we are having 12, and 12 divided by 4 gives 3, and minus 2 divided by 4 gives minus 1 by 2, 4 by 4 gives 1, and 0 by 4 0 gives, and 1 by 4 gives 1 by 4 0. Okay, and after that we want to find new S1 value, and as well as new S1 value as well as new S3 value. So we have calculated using the formula word new pivot equation, new pivot equation is equal to old pivot equation divided by pivot element, and whereas the equations are given by remaining new equations are given by see, I'm writing here new pivot equation equal to old pivot equation divided by pivot element. Okay, and the remaining new other equations. Okay, new other equations is NE equal to old other equations minus pivot equation, that is new pivot equation into corresponding pivot element, corresponding column element, pivot column element, okay. So here 4 is the pivot element, so this is pivot column. So for first S1 we are having old equation minus pivot equation into so here we are having minus 1 into minus 1. Okay, so we are having 3. So here we are having 7 minus 10 into minus 1, that is 7 it is 7 minus 3 into minus 1, that is 7 minus 3, and will give you 10. Okay, and here also it is 10 minus 3 into 3, that is 10 minus 9 equal to 1. In the same way we have to calculate remaining values of this row, so we are having once again calculated Zj star minus Cj as before, as similar to previous iteration, and we are having one more negative here. So now this column is called pivot column, and here we are having minus 1 by 2 here. So 3 divided by minus 1 by 2, and we are having 1 divided by 5 by 2, 1 divided by minus 5 by 2. Okay, so 1 divided by minus 5 by 2, so we will get only this, that is 20 divided by 5 equal to 4. So this is called the pivot row. Okay, this is called pivot row. This is pivot row, and this is pivot column. So intersection of pivot row and pivot column is the pivot element. So we want to divide all this by this pivot element. So 10 divided by 5 by 2 is 20 divided by 5 equal to 4, 1, 0, and 4 by 5. It goes on like that. 4, 1, 0, 4 by 5, 2 by 5, 1 by 10, 0. And second equation becomes, second equation I'm calculating using the formula. This is our new equation. So new equation is equal to old equation minus new equation into corresponding pivot column element, in the pivot column. So the important thing we want to know is, whenever we are having a pivot element, here pivot element appears in S2, so S2 becomes the leaving variable and X3 becomes entering variable. So we want to remove this S2 and we want to have X3 here, and the coefficient of X3 also comes here. That is what we are having in the second iteration. Okay, and after that here the pivot element appears in S1 and X2. So this S1 is the leaving variable and X2 is the entering variable. So we are having minus 1 here. Okay, so similar to the previous iterations, after calculating this Zj star minus Cj, we are having this value as 11. That is minus 1 into 4 plus 3 into 5 plus 0 into 11. Okay, after adding all this we will get 11. Here minus 1 into 1 plus 3 into 0 plus 0 into 0 minus of Cj. So minus of minus 1, that is we are having 0, 0, 12 by 5, 1 by 5, 4 by 5, and again 0. So here all the Zj star minus Cj are greater than or equal to 0. All these values are greater than or equal to 0. So we can take this as minimize of Z star equal to maximize of Z star equal to 11 and X2 equal to 4 and X3 equal to 5, and there is no X5, so X5 equal to 0. So X5 equal to 0. This is our solution. So maximize of z star equal to 11, x2 equal to 4, x3 equal to 5, x5 equal to 0. So we know that maximize of z star can be written as minimize z of minus 11. So minimize z equal to minus 11, x2 equal to 4 and x3 equal to 5 and again x5 equal to 0. So the problem comes to an end here. So this is our solution. I hope you will definitely work out this problem and you will definitely understand how this problem gives solution using simplex method. Okay, so this is Dr. D. Prasanta Bharji signing off from this video tutorial. Thank you. Let's see once again with a good problem with an important technique. Thank you so much. Thank you once again.